All right, welcome back. This is going to be the second half of section 4.3, exponential functions. All right, so we've looked at the graph and some of the properties of exponential functions. Now I just want to mention a couple of other things. E is considered the exponential function. In calculus, this is defined as the limit as n goes to infinity of 1 plus 1 over n to the n power. Now you don't need to know that, I'm just telling you where it comes from. This is a number that occurs naturally in a lot of, especially biological applications. I'll give you just an estimate for it. 2.718281827 and so forth and so on with no particular pattern. So this is a number a lot like pi that goes on forever and ever with no obvious repeating pattern in it. This number is also stored on your calculator. Let's see, on my calculator, my TI-30, if I press second ln, I get e to the x. So do just e to the first, and you should see this decimal on your screen. All right, so now let's look at solving exponential equations. You'll see this number come up some within that. So solving exponential equations, still part of 4.3. Okay, so here's the property that they give. If a to the u is equal to a to the v, then u equals v. So in other words, if you have the same base on both sides of the equation, you can essentially set the exponents equal and solve it that way. Okay, so this is picking up with my numbering from the previous one, number 4. And we just want to solve the equation. So here's the first one. 3 to the x plus 1 equals 81. Now currently these are not written with the same base, so my first goal is to get these written with the same base on each side. So I'm going to leave the 3 alone. That's kind of as simple as it gets. And then I want to write 81 in terms of 3 to some power. So 81 in terms of powers of 3 would be 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th. Okay, now I've written both of these as the same base. And then at this point I can just drop the base and set the two exponents equal following that property. So x plus 1 equals 4. And then just finish solving that, subtract 1 both sides, and you get x is 3. Okay, so to solve these, you're trying to write both sides as the same base. All right, let's try this one. 4 to the 2x minus 1 is equal to 8 to the x plus 3. Okay, so I want to look at the bases 4 and 8. 8 cannot be written as a power of 4, so I want to break both of these down to a different base. So I'm going to use base 2, so 4 in terms of powers of 2 would be 2 squared to the 2x minus 1. And then 8 in terms of powers of 2 would be 2 to the 3rd to the x plus 3rd. Okay, so now these are both written as the same base. If you remember your exponent rules, I'm going to do power to a power right here and multiply these. So I'll distribute this 2 into here first. So base is 2, distributing the power of 2, so I'll get 2 times 2x, that's 4x. 2 times negative 1, that's negative 2. Other side, distributing this 3. So I've got 3x plus 9 in the exponent over here. All right, so now they're both written with powers of 2. Using that property at the top of the slide, I can just set my two exponents equal and go from there. So 4x minus 2 equals 3x plus 9, and then solve that equation. So I'll subtract 3x both sides. Leaves me x minus 2 equals 9, and then add 2 to both sides. And that gives me 11. Okay, so starting out by writing both sides of the problem as powers of 2. So trying to get the base the same. All right, the next question uses that base e. This will be number 5. So this says e to the negative x squared equals e to the x to the second, it's kind of a weird way to write it, times 1 over e squared. I'm sorry, e to the third. Now remember that e is a number, 2.718, blah, blah, blah. So we're solving for x, we're not solving for e. E is a number, not a variable. The first thing I want to do is go ahead and kind of condense that right side to get it down to just 1 e. Okay, so leave the left alone for right this second. Over here, if you follow exponent rules, this will be e to the 2x, right? This is like over 1, and I'm multiplying, so I can put that on the top of the fraction over e to the third. So I've got it as one fraction now. Okay, keep going, thinking exponent rules here. When I divide like bases, I'm going to subtract exponents. So keep the base e, and then my exponent will be 2x minus 3. So now on each side I have base e. Okay, following the property from the previous screen, now I can drop the e's and set the exponents equal to each other. All right, now to solve this, because of the squared term, I do want to get everything over to one side and get it equal to 0. I'm going to add x squared to both sides. You can move it either direction. I just like that x squared to be positive. Okay, and then solving this, it is a quadratic, so I'll try to factor. So I'm going to say what multiplies to get negative 3 and adds to get 2. So that would be, ooh, I clicked the screen. Sorry about that. Let me just continue in that problem where I was. So here's the quadratic we're trying to factor. Sorry about that. Okay, so I'm going to say what multiplies to get negative 3 and adds to get 2. So that would be x plus 3 times x minus 1. Okay, now 0 product property, so 2 problems and 2 answers. 0 equals x plus 3, and then separately 0 equals x minus 1, and solve both of those. Okay, so 2 answers to this one. All right, and that is solving exponential equations. So for now, for solving exponential equations, your goal is just to get the same base on each side of your equation and then set the exponents equal. Okay. All right, so that finishes up 4.3. Go ahead and go to the next one to see the next section, 4.4.